February 18th, 2021.
About 20 meters off the surface.
NASA's Perseverance rover successfully touches down on Mars.
On the surface of Mars.
Among the payload instruments and sensors aboard, PIXL, planetary instrument for X-ray lithochemistry. PIXL's mission? Study ancient Martian rocks, searching for signs of past microbial life. Now published in Science magazine, the initial results of that search: an olivine cumulate outcrop on the floor of Jezero crater, Mars.
This is the first peer-reviewed paper published using PIXL observations of rocks on Mars. This is the culmination of a decade's worth of work by a lot of people.
Tim Elam is senior principal physicist at the Applied Physics Laboratory at the University of Washington. Tim describes himself as chief spectroscopist for the current Mars mission.
The PIXL is an X-ray fluorescence spectrometer. That is, it measures the energy of X-rays emitted from a material, and then the intensity of each of those X-rays tells us how much of that element is there. So my job all along has been to model and help design and build and test the X-ray spectroscopy part of PIXL.
To save power, PIXL works at night while much of the rover sleeps.
And so what's happening is that PIXL is just moving from one point to another on the rock and collecting X-ray data and occasionally optical and image data so that we can get a comprehensive data set.
PIXL X-rays work in very fine sub-millimeter scales to identify chemical elements in Martian rocks.
To cover a square centimeter or so of the rock takes several thousand points. So each one we have to spend about 10 seconds in order to get enough X-rays to do any kind of elemental quantification of the major elements. For the results in this paper, the main thing is I wrote a set of software that takes the X-ray spectra and converts it to elemental abundances, that is, which elements are there, iron, silicon, and how much of each one is there. And you can see each of the different points that we've measured in this raster scan is over here on the left, overlaid on a visible light image, so that we can tell where they all are on the image that one would see with one's eyes if one could stand on Mars. The history of a rock is contained in the set of minerals that are in there because they all form at different temperatures and pressures and under different conditions. And the set of minerals and how they're arranged allows them to say a lot about the history of that rock. And this particular rock, it's called Brack is the name of the rock, and then Durbs is the name of the little patch that we are investigating where they made a nice flat abrasion. That's in this CTUF formation, and it's pretty clear that it's igneous.
PIXL's search on Mars for traces of microscopic life dating back billions of years continues. For more information, go to science.org.